This is our next video for SLO9. We're going to continue with two sample hypothesis tests, but we're going to look at paired rather than independent data. Remember that when we do paired data instead of independent data, what we'll wind up doing is we're really examining only a single test statistic, which is the mean of the difference between the two sample means, which we call D bar, D for difference. Now, how do we perform such a hypothesis test? Well, it's pretty similar to what we did before, along with the same sort of methodology we used for paired confidence intervals, right, in Chapter 10. First off, as always, we state our null hypothesis, as well as whichever alternate hypothesis we might have. Might be this guy, could be this guy, or this guy. Right. Now, next up what we're going to do is we're going to let D equal just each paired point, like the first paired point minus the second paired point, right, and etc. So we'll just say sort of paired difference. Okay? And then we're going to let D bar equal the mean of D, right? And then we'll also let S sub D equal standard deviation of D. Okay? Next up, we're going to find the critical value, T, given by T equals, now this is going to be a lot less complicated than last time. Remember we had that big square root of the blah, blah, blah? Here, it's just going to be D bar minus, well, our hypothesized difference, which is going to be 0, divided by, and then all this is the standard error, SD divided by root n. Right? That's it. So really, you could say it's just D bar over the standard error. And at this point, we're just doing a one sample t-test on this, right? Like really what we just did, right? This is a one sample t-test on this, rather, right? Right, so anyway, we want to find the p-value corresponding to our t-score, or critical value, with, and remember, it's just n minus 1 degrees of freedom, right? Because there's only one number, right? Everything's paired. Anyway, if p is less than or equal to alpha, then we reject the null hypothesis, and of course we say that the results are statistically significant, and if p is greater than alpha, then fail to reject H naught. And our results are not statistically significant. If necessary, state the conclusion about our problem. Now again, note that this is a hypothesis test on the parameter, I guess we could say mu1. Well, I guess you could say it's sort of a mu1 minus mu2, but really we're using the test statistic D bar. So anyway, here's a sample of 5 matched pairs, right? Let's just, let's answer these questions, right? First, we compute the differences. We don't really need Minitab for that, right? We can just do that, right? Right? So part A, tacky to draw an arrow, but I'm just going to do that right there, right? Compute the test statistic, right? Now, this requires just, you could do this no problem, right? You could easily find the mean. You could find the standard deviation. But let's see. Do we have this on Minitab? We sure do, right? So let's just go ahead and do basic stats, display descriptive statistics. Oh, and actually, sorry, shoot, you know what? I should actually go ahead and write the difference column in there. So let's go ahead and write difference, right? So we're going to have, let's see, 1, -4, 6, 9, and 7. All right. And so at this point, we can do stat basic stats, display descriptive statistics. We can consider the difference column. And which statistics do we want? We don't care about the min, max, none of that. Whoop. Don't care about missing, not missing. Standard error might be nice, but we don't really need it. Let's see. They just say compute the test statistics. So I guess actually, really, we just need the mean. Right? If all they want is the test statistic, then we just get that, right? Maybe we didn't actually have to do all that. Maybe we could have just, done d bar equals 1. I guess we could have just done 1 minus 4 plus 6 plus 9 plus 7 divided by 5, and that winds up being 3.8. But if this were more complicated, right, we would do that, right? So we get this, right? And they say, do you reject H naught, right, at this level? Well, here's where we can really, I guess, use Minitab a little bit more, right? Here we go. Stat, basic stats, and we're going to do paired T at this point, right? Each sample is, in fact, in a column. Sample 1 is going to be here. Sample 2 is going to be here, and here we don't even need difference, really, because it's going to do the difference for us. Let's start off with a 0.05 significance level. Let's actually see really quickly. Alternative hypothesis is greater than, actually. So let's just do that. So anyway, we do this. Okay, we get our stuff. And anyway, we get our t value of 1.61, which is nice. P equals 0.091. And so the answer is no. Right, we can't reject the null hypothesis at either level of significance. Yeah, I'll say so no. We can't reject H naught for alpha equals 0.05 or alpha equals 0.01 because P is greater than alpha in both cases. All right, that's it. All right, next example, right? Let's see, we have an actual word problem here, right? Crossover trial for two types of drugs. They took the drugs. Here are the results. I guess we have pain levels, and the question is the mean pain level less with drug B, right? So here are the null and alternate hypotheses, right? We have mu, I guess you could say mu A minus mu B equals 0. If just be a little careful with the alternate hypothesis. If you phrase it like this, it would be if the pain level is less, then that means that mu A minus mu B would actually be greater than 0. Just want to make a quick note of that. Right, less with drug B. Right, that means that, right, mu B should be less than mu A, which means their difference should be greater than 0. Right, if you wanted to do B minus A, then it would be less than 0. Okay, but those are the alternate and null hypotheses. Now compute the test statistic. Again, we could even do this by hand if we really wanted to. Right, D is going to be, I'm just looking at the difference here, etc. We could do this by hand, actually, right? 1, 2, -1, 0, 2, -1, 2. So the test statistic is D bar, which is 1 plus 2 minus 1 plus 0 plus 2 minus 1 plus 2 all over 1, 2, 3, 4, 5, 6, 7. What does that wind up equaling? Well, let's see. We have 3 minus 2, 4, 3, 5. I've got 5 sevenths. All right. And so we state our conclusion. Well, we could go ahead and do all this, but I'm pretty sure that if I zoom out a little bit, there we go, that I've got these pain levels done. Stat, basic stat, paired T. Let's go ahead and put the correct thing in here, right? Drug A. Drug B. options. What confidence level did they say? I didn't even see. Yep, 0.05 significance level. And we do actually want to keep it at greater than. All right. And let's see what we have here, right? The p-value equals 0.110. All right. So I'll just write both of them, right? Since t equals, is that 1.37? Yeah. We don't really need this. P equals 0.110, which is greater than alpha equals 0.05. We fail to reject H naught. Now note that they say state a conclusion. So let's use words here, right? So there's not enough evidence that drug B causes less pain than drug A. So we've got that. All right, let's do one more example, right? First, some generalization. What do we need to do? What do we need to know in order to be able to do matched pairs? Well, the sample has to be random, right? We always require that. And that, sure enough, the sample is either large, greater than 30, right? Or the difference, D, between the pairs is, I guess I'll say normal or approximately normal. All right. Now, one last example. We won't be calculating anything. The calculator already did the work. This is just making sure we know how to interpret a display. So let's see. Is this a left-tailed, right-tailed, or two-tailed? Well, I've got mean greater than 0. So let me actually just highlight that and say, well, I guess that means it's right-tailed. How many degrees of freedom are there? Well, n equals 18. So the degrees of freedom equals n minus 1, which equals 17. What is the p-value? Well, p equals 0.17457666435. Goodness gracious. And then, can H not be rejected at the 0.05 significance level? Absolutely not. Since p is greater than alpha, which equals 0.05, we fail to reject the null hypothesis. That's it.